Hello, good morning, good afternoon. Welcome to the DCSA IoT webinar. My name is Ellen Sun. I'm in charge of marketing at DCSA. And today on this call, there are four of us, Henning, Marcel, Andre, and myself, all dialing in from home, from Germany and the Netherlands. So with that, I'm going to turn it over to Henning, our COO.
Many thanks, Ellen. And also from me, welcome to the IoT webinar. I'm Henning Schleierbach, COO of DCSA, and with the company now since almost a year. Today, we at DCSA are proud that with IoT, we have now published our first standard for a really new area. It's an area which is developing rapidly, and it comes with a bunch of potential new use cases. So compared to the publications that we have done earlier, this is really interesting for us, and it's a special area because we believe we can really make a difference in this field by providing standards as a basis for further development. Next slide, please, Marcel. Allow me 1 minute to introduce you to DCSA. The Digital Container Shipping Association has been established in 2019 with our headquarters in Amsterdam. This is also why at least some of us are dialing in from Amsterdam right now. We have 9 of the world's top 10 carriers as our members, and they all in all represent about 70% of world's containerized trade. You can find their logos here on the right. DCSA aims to further the digitization of global logistics, and in particular, the part of container shipping. Our standards, however, are also looking at multimodal supply chains, so we have that always on our mind. Our organization is neutral, it is non-for-profit, and we publish open source. So the publications that you can download from our website are free for you to use. Next slide, please. We have structured today's session into 4 parts. After this short introduction, Marcel will provide you with our perspective on the industry trends and also the reason why we have selected connectivity standards as our first IoT publication. After that, he will dive into the details of the recommended use cases and connectivity standards. And finally, we have room to answer your questions. So please type them in so that we have them at hand when we go to that part. And with that, I am happy to hand over to Marcel van der Poel.
Thank you, Henning, and good morning and good afternoon to all of you in the audience. My name is Marcel, and within DCSA, I am responsible for the IoT program. And in the upcoming 30 minutes, I want to take you through our publication. With me, as Ellen already mentioned, is Andre Santiago. And Andre is the technology lead of the team. So any really difficult technical questions, I would always happily refer to Andre. But let me start. Let's take a typical container journey. And let's say it starts at a factory where it's loaded with goods. And then it goes on a journey. And there are trucks involved. And there might be barges involved. There might be trains involved. And probably somewhere in between, there is going to be an ocean-going vessel involved as well. And then it goes on again, maybe again with a truck or a train or a barge, and it ends up at its final destination. What we as an industry want on that entire journey is end-to-end visibility on where the containers are, what their status is, how are the contents of the container. And we have seen the industry, IoT providers, our members already invested quite a lot in solutions. However, what we've also seen is that the interoperability between those solutions is not there yet. The clearest example probably is that the visibility, the end-to-end visibility stops when a container gets on board of a vessel from another carrier. And there is no interoperability anymore. Because carrier A has developed a certain IT solution, and that is just not compatible with the solution that is used by the carrier B. And unfortunately, that vessel or that carrier takes the container from A to B. Now we know that if we want to improve on that, if we want the IoT to really take off more than it's even doing now, we require digital standards. And that is the objective of the DCSA IT program. We want to be able to have seamless digital interoperability through the use of our standards. And in this day and age of digital, it's all about data sharing. So one of our foremost objectives is to simplify data sharing throughout the container journey across the entire industry for all the stakeholders involved. Our members, the carriers, but also our customers. What we have seen with our members is that, and I'm going to take you through that later, we have a bunch of use cases that we use as a basis. But we know from our members, we know from the IT providers that they have a long list of many more use cases. The reason why they're not using all of them yet is because for them, they're just not sure yet which use case is worth the investment. And that brings me to the third point. Through our standard, we want to reduce the risk of investments in IoT. And that goes, as I just said, for our members, but it also goes for other vessel owners. Which IT solution should they invest in? Which technology to invest in? It goes for the IT providers, but it also goes to the end customer. By providing these standards, we want to be able to reduce for the entire industry that risk of investment. A few key terms, and then I also want to discuss the scope of our publication and the reason behind that scope. First term is the IoT gateway. A IoT gateway is actually nothing more than a DSM cell tower. It is in that sense an intermediate between an IoT container device and the internet or a local system, just as a GSM tower is the intermediate between our smartphone and the internet. Then we have the IoT device. An IoT device is also an intermediate for communications. And there it communicates between the sensors inside or outside of the container, other IoT devices, or the gateway. So two terms, IoT gateway and IoT container device. And it looks like what you see here. So there's a sort of two steps in that communication, from the IoT container device to the gateway, and then either to the cloud or a local system. What we have taken in scope here is the first step between the container IoT device and the IoT gateway. So explicitly out of scope is the second step from the IoT gateway to the cloud or a local system. And there were some reasons for that scope. But let me take one step back, because within those two IoT gateway and container IoT device, DCSA has for now elected to focus solely on the IoT gateway. And the reason for that is that the competitive advantage for the carrier is in the data it collects. That data will help him improve operations or improve customer experience. And that is something we do not want to touch. We've already seen that the gateway on board of the vessel, or in general, the interoperability on board of a vessel, is right now the breaking point for the end-to-end visibility. So that's why we wanted to focus on standardizing the IoT gateway. That also makes it easier to connect to other infrastructure owners. Think terminal owners, or freight station owners, or the owners of an inland container depot. If they adhere to these standards, for them as well is the much higher probability of return on investment on their investment. So several reasons for that. Now, you will see the part that is in scope later referred to as the internal interface. whereas the part that's out of scope is the external interface or the backhaul. Okay, now I want to go through the use cases. And we have seen, based on the shortlist that we have from our members, we have identified 3 groups. And they belong together based on the requirements, locations, functionalities. And I'll start with group 1, and that's the Reaver group. And the Reaver, as we all know, has got a permanent power supply. And therefore, the, let's say, level of sophistication of the use cases was a bit higher. So the first group is about the Reaver container sensor and other data, monitoring, tracking, and remote control. The dry container, without the permanent power supply, has a group of use cases around the sensor data, monitoring, and tracking. And both of them are for the on-land applications as well as the at sea. Now, the third one is the sort of odd one out. That's the automatic electronic containerization, purely for on-land purposes. And I will go into the specifics of these groups of use case later. But for now, let me say that what we found is that where this is, say, from a technological perspective, fairly basis standard, we do believe that adherence to the standard will bring a lot of value throughout the entire value chain. So we have those groups of use cases. And we know that there are gateways for each use case group. Now, for this specific exercise of identifying which types of gateways we have to use, we have coupled use case groups 1 and use case groups 2. Now, the type of gateways that we have identified can be split into 2. One is the gateways that enable smart container connectivity on the vessel at sea. The second one does the same thing, so it enables smart container connectivity, but it does it on land in either a static environment or a moving environment. In a static environment, you can think of the entry or the exit of a terminal, or the freight station, or the inland container depot. The moving environment on land is, of course, the train, the truck, the barges. So for those environments, we have 2 types of gateways. For use case group 3, we have also 2 gateways. Now, use case group 3 is all about automatic electronic container registration. So that means that you can identify the container throughout its journey on fixed locations. Again, those terminals, inland container depots, the toll plazas. But it also works with a handheld device or operational teams to identify this specific container. So here we have seen specific groups of use cases, the types of gateways that we need in that for those groups. And what we now want to take you through is the internal radio interfaces that we have selected as a standard. And actually what you're looking at here, this one slider, is the result of what we've been doing over the past 6 months, starting in November 2019. And I think this is also the moment where I want to thank our members, because we've been working very intensively with our members. We have a group of subject matter experts, about 20 people all in all, and we've worked on a weekly and sometimes on a daily basis with them to determine the use cases, to determine the requirements, to look at what's out there that best meets those requirements, to select those gateways, and to select those internal radio interfaces. So thank you to our members and the subject matter experts. Now, back to the internal radio interfaces. If we take the first group and the second group together, and we know that there are at sea and on land, and if we take the at sea one, we have the on-vessel connectivity as a functionality, and the gateway type is the gateway on the vessel. So looking at it horizontally on the top of the visual. The first internal radio interface that we selected is the cellular. And I think that's clear why we've done that. It's omnipresent. It's very cheap in use, and it brings good functionalities. There are also some setbacks, but I'll get to that later. In the cellular, we have selected 4: 2G, 4G, LTE-M, and narrowband IoT. And let me take you through them and also explain why we didn't select 3G and 5G. Now, to start with, 2G is everywhere and it's cheap. And it does what it needs to do. It's not extremely sophisticated, but it covers a lot of the use cases that we have. 3G is less omnipresent than 2G, and it shares the same functionalities with 4G. Hence, in the comparison to 2G, 4G, we felt 3G could go. So we have 2G, we have 4G. We didn't do 5G yet because it is not present enough around the globe for us to consider it a candidate for a standard. Will that change? Very likely it will change. What we do have related to 5G is the LTE-M and the NB-IoT specific radio interfaces. Now those two are fairly similar in use. They have technical differences. Latency, data load are some differences. There is some difference in costs, but not that much. So what we see is that it really depends on your specific type of use case to select between either of these two standards. As I said, cellular is not perfect. I think two main limitations come to mind. One is that cellular is not very good in a constrained environment. And if a container vessel is anything, it's a constrained environment. And another thing that cellular doesn't do really well is to handle a high density of devices. So we have looked at possible additions to cellular. And we've decided on LoRaWAN, specifically the sub-gigahertz version in the ISM bands, and the Bluetooth 2.4 gigahertz also in the ISM bands. Now, LoRaWAN has as its major competence the ability to act in constrained environments. So that is the reason we choose it. What it doesn't do well, just like cellular, is cope with a high density of devices. Now, Bluetooth can do exactly that. So for us, the combination of cellular, LoRaWAN, and Bluetooth is the ideal package where they compensate for each other's weaknesses and bring their own unique strength. If we look at the gateways on land locations, we see that we can't use cellular because cellular has license bands. And where on board of a vessel, you can create your private network 20 miles from the shore, and on the shore, you can no longer do. So that's not part of our standard. But the same LoRaWAN and the same Bluetooth is part of our standard there. Then for group 3, the automatic electronic container registration. So think the container that has a sticker on it that has the same information on that sticker that is now written out on the container. And that container goes on a truck, and the truck drives on a highway, and it passes a toll gate that is equipped with this kind of standard. And immediately it is registered. And the same goes for if it enters or leaves a terminal or whichever location. And that's the event-based connectivity, so sort of the fixed location. Now, what we have as a standard for that gateway is RFID in the ultra-high frequency ISM bands. And RFID has as an advantage that it is enormously cheap, that it uses very little to no power, and that you can get it anywhere. It also has a disadvantage. There is a limited range, and there is only so much data that you can transfer via RFID. But with this specific use case, the automatic electronic container registration, we believe that those limitations of RFID do not play a major role. If we go to the handheld gateways, so think operational teams, again on the terminal, in the inline container depot, the freight station, they walk around with handhelds. Could be their smartphone, can be a iPad-like equipment, and it can be a specific device. For that, we have worked on NFC. We've selected NFC as the standard. Again, ISM bands. So both RFID and NFC license-free, so able to use it anywhere. And dear audience, this is it. This is where we've worked on for 6 months. This is the overview of the standards that we believe is a first step, a major first step, and still just a first step in creating the standards for the entire shipping industry when it comes to IoT. Now, we also have thought about the next steps, and I want to slowly or quickly actually take you through it.
Marcel, if I may, before we go there, if you mind to go to the previous slide, I'll just like to add a quick note on the selection of the technology, especially for the first two groups, and a small remark. So as you said, we haven't seen today any technology that can single handle all the requirements that we had for these use cases. Hence the option for more than one technology that was standardized in this publication. A quick remark or some questions that we had on the last webinar were regarding the option for the Lotto 1. I would just like to add some additional notes. So as you said, it's an important technology that supports the propagation, the connectivity propagation in more constrained environments, especially because of the use of the 433 megahertz frequency band. We know that today, for instance, one of our members is already deploying a Lotto 1 based solution in their larger vessels, and with only one gateway, they can cover the entire vessel. So that is one of the particularities of this technology that make us select it. And also another quick remark is in terms of the on-land gateway. So cellular is not part of the standards for the gateway. This doesn't mean that they cannot or that cellular technology cannot be used on the IoT device. So since the gateways, we are assuming that the gateways will be deployed by the industry stakeholders that are not telecommunication operators, they will need to have a license to operate cellular networks on land, and that's why we have excluded cellular on this specific location. That's it.
Okay, thank you, Andre. Looking forwards, release 1, we just had it 2 weeks ago, and we are already working on release 2, also with our members again. In release 2, we want to focus on more of the communication protocol layers. What you can see in the publication is that for this standard, we've been focusing mostly on the OSI model, and specifically there on the physical and MEC layer. What we're going to do is also focus on the other layers. What we're also going to focus on release 2, which will, by the way, be for 2020, the remainder of 2020, is the data structures and handling requirements. We're going to be able to inform you specifically on what we're going to do a bit later on in this month. But for now, this is the high-level scope of what we want to do. Release 3, what we have in mind now, will be in the second quarter of 2021. And there we want to talk about security requirements, physically and software ones, for the IoT devices. So where we've now focused on the gateways, release 3, we're going to focus, for the part at least, on the IoT devices. And that's it for the content part. I now want to hand back to Henning, and also for the Q&A. Henning, back to you.
Yeah, thank you, Marcel. This is just one quick slide I would like to share with you. And it is in the end we sometimes get the question, how can we influence the standard you're publishing? Is it a closed shop? How does DCSA deal with feedback? And maybe there, most important to mention is that we have been working with a couple of solution providers and standardization bodies already during the publication and before the publication. But we are also open to your feedback, and the webinar is just one channel that we would like to use to get your feedback. So first of all, on our website, dcsa.org, you can find all the publications under initiatives. Feel free to download them or read them online. When you're reading them online, we are using a small snap-in called UserSnap that you can use to provide feedback or questions to one specific part. In the end, it just lets you take a small screenshot of the section where you're at, so you can connect your question right to the diagram or section of the publication where you have a question or feedback about. And we usually get back to you on these ones quite quickly. As mentioned by Ellen in the introduction, we also want to follow up with you on this webinar with a quick survey, and please take a few minutes to share your feedback with us. That helps us to improve not only our publication, but also these kind of webinars going forward. And there's one more topic. So the survey also lets you register for our reference user group. With that, we are primarily focusing on shippers and forwarders, as they are our members' customers, and by that play a very important role, of course, in all the standardization work we are doing. However, if you're not one of those, please provide us just with a reason why you want to collaborate with us and what you think is in it for us as well. And with that, your ongoing collaboration with DCSA will ensure that we focus on the right topics, and our publications really help to change and ease the whole ecosystem. And with that, I would like to hand back to Ellen to guide us through the questions. I have seen a couple of interesting ones already, and we now have more or less 15 minutes to go through the most important ones, and the remaining ones we will get back to you in written.
Yes, okay. We do have indeed quite a few already in, and let's start with the broader questions, and then we'll see how much time we'll have to go into a lot of the more detailed stuff. The first one, maybe this one's for Marcel. Can you talk about what the compliance requirements are?
Yeah, sure. So compliancy for the gateways, and that's what we've been focusing here on, is really that a vessel provides those three standards across the entire vessel. So a gateway provider is compliant with those standards if he or she provides all three standards. That's different for a IoT solution. The IoT solution for a container device is already compliant if he uses one of the three, be it cellular, be it LoRaWAN, be it Bluetooth. In this configuration between the IoT device and the gateways, we've seen that the gateways need to provide interoperability. So that's where the sort of most strict compliancy requests are. Back to you, Ellen.
All right. Okay. There is a question about our collaboration or relationship with UNC-FACT. Maybe this one is good for Henning. Henning, can you talk about that?
Yeah. So already with our publication on classical track and trace, we have been collaborating with UNC-FACT and also based our standards on their reference data model. The same goes for IoT. So we are very well aligned and aware of their IoT initiative. And as Marcel pointed out, in release 2, we will now be looking into security and data and interface standards. So while the first release has assured that the device, in the ideal case, has connectivity at any place in the world where it may end up, we are now focusing on what type of data for which kind of use cases do we want to transfer, because that requires standardization as well. We will base that on the work of UNC-FACT, which doesn't mean that we need to follow it 100%, but this is the detailed discussion that we will have with our members. And I'm also very happy that we could convince Hanan, who was leading the UNC-FACT, or who is leading the UNC-FACT group, sorry for that, yeah, to work with us in DCSA on exactly these topics.
Okay. There are a few questions, so this is where Andre, you may have to help me out here. There are a few questions actually related to data formats. I think you answered some of that, whether we're going to be standardizing on data formats. There's a question around any ISO standard being formulated.
Andre, you want to take the one on the standards?
Yeah. So in terms of the standards and data formats, that's part of the scope for release 2 that we started the work now after the publication of release 1. So we'll be hearing some more news on that, but the goal is now to go back into the application layer and to formalize with our members what are the minimum set of requirements that need to be standardized there, and then focusing on publishing data formats for the data that are going to be exchanged between the IoT devices, the gateways, and the cloud. And if I'm not wrong, the goal for publication is by the end of the year of 2020. I also see here, Ellen, an interesting question regarding the usage of RFID, and why haven't we considered other types of alternatives such AI and computer vision? Let me just give a brief experience of what our members pass to us. So some ports and terminals are already using the optical character recognition types of solutions, and the experience is not so good to read the information that is on the container. So this use case of electrical registration of the containers through RFID appeared as an option to tackle this poor experience with other technologies that were being applied in the industry. This doesn't say that in the future those same alternatives will not improve and be a better support, but as of today, the overall experience in the industry is quite poor in terms of video recognition for identification of containers.
Okay, thank you. There's actually a quick follow-up.
Sorry, let me. This is Henning. Let me add to that one. Maybe that was not clear from the presentation. So it's not only about the container number where I can see computer vision really adding value, and I also understand that use case of reading the license plate from a truck plus the container number and combine that information to get, for instance, better ETA of a box. What we also think is required is to get information about year build, tear weight, size type, and other things that are written. I mean, they are more or less stamped on the CSC plate of the container, but there is no way to electronically read or capture them right now, also not within OCR. So usually you're relying on global databases that have more or less up-to-date information of that, which is not always the case. So we believe that this is also one essential element that can be enabled by RFID.
Okay, thank you. There is actually one quick question, quick clarification question, and then there's one that I want to highlight that also came up yesterday. The first clarification question is, can you explain what UNC fact is, Henning?
Yeah, actually, I was just about to input the web address. So UNCFACT is a UN organization looking into standardization. So they have, for instance, created the EDIFACT model, which is currently I would say the backbone of data exchange in the supply chain industry. And they are working on this since long term. So they have a couple of working groups. They are also looking after the UN low codes that you are probably aware of, that we use to identify cities or ports. And they have quite a comprehensive package of standards published. But I will provide the web address to give you more information about that.
Great. Okay, the question I wanted to highlight which came up yesterday as well, is what the role of COVID is in accelerating the uptake of digital standards.
Yeah,
do you want to take that one?
I'm happy to take that one. It has a twofold impact. So on the one hand side, it is of course hindering us from collaborating with our members as good as we were able to do it before. So there is a difference, and I'm a strong defender of that opinion, between meeting face to face at least every once in a while and just virtually. However, we are continuing our work, and on the positive side, we can see that COVID has highlighted the vulnerabilities and inflexibilities of global logistics supply chains. And we have all seen that. So some goods are required more, some others are less. So we see that space is occupied by equipment which is still laden and not picked up at the import side. And we saw blank sailing. So that was really a stress test for global supply chains. And one thing that it made pretty evident is that there is a need for digitization. And it is, for instance, better if you can download your electronic bill of lading than if you have to courier it from an office where maybe at the moment nobody is working because everybody is working from home. So just this as a maybe very small example, but these things have happened, and they have also highlighted the need to digitize rather faster than slower in the global logistics industry.
Okay. Thank you. There was one question that came up yesterday about NFC that I also saw a similar question today. I'm trying to find that one. Let me first start with the one that came up yesterday. Can you elaborate on the choice of NFC?
About the distance, the limited distance of NFC on most cell phones?
Yes.
And if that would still work for the operations teams. I remember the question, but I'll leave the reply for Andre.
Yeah. So the handheld gateway, the vision, let's say that its main task will be mostly to configure devices. So for maintenance teams, when they are deploying the device or when they are doing some maintenance on the container, this will support them on doing configuration that today, at least because we already see some solutions of RFID tags implemented in real case scenarios, huge cases in India, for example. And we see that the configuration of those devices is still being done mostly manually or supported by manual activities. And the use of NFC can support these teams on when they are doing the maintenance or the implementation of the device to easily configure the device with the container ID, etc., and the other information that they want to storage on the device. So that's one of the reasons. The second reason is this is something that can, because it has a really low cost to add this NFC tag into an RFID tag or into a more robust IoT device, and it can help for the operational teams if they want to quickly access what is inside of the container, what is the information, to quickly use their mobile phone or any other type of mobile gateway through NFC to access that same information. So it's not specifically to do the registration on all of the containers while they are on a port, in a terminal, on the vessel, but more as an alternative solution that the operational teams can use when accessing information on the container device.
I want to see if there's any other quick one that we can answer that will be easy to do with a big audience.
I think the last one, Ellen, is interesting. Who will provide the IoT devices for the container? And that is, it's of course an interesting question because it goes into the commercial model that is behind it. So there are a couple of solution providers out there in the field with solutions for reefer, tank containers, dry containers. And the RFID labels is a completely different area, I would say. So at the moment, it looks like the container owners, which are normally the carriers, are buying this. However, we've also seen solutions that you can just clip on as a shipper, and that will provide you with data. And ideally, if the gateway technology is on the vessel, you will have no blind spots throughout your chain. And it might also be a topic for container leasing companies at a certain stage. In the end, the beauty of providing the device is that you always will be the data owner. And the disadvantage is you have to pay for the traffic, for the device, for the license. So you have to commercialize that with whoever your customer may be. So in the end, you have to come up with an interesting model that really adds value to your shippers. So that they are willing to pay for this information. And you may also find some operational advantages from having way better visibility of where your fleet is that you can commercialize or that you can use to save costs internally as a carrier.
Should we do one more? There's one, I'm not sure if this is a quick one to answer, just while everybody's on the line. This question is about the security of Bluetooth technology. How do we address that so that information doesn't get picked up by, by malicious people?
Yeah, I can also pick that one. So in terms of security, we still haven't went in a deep analysis on the technologies. When we were selecting the technologies, of course, we had that in consideration, especially the encryption methods, since we were just focusing on the physical phase, the physical layer. Apologies, but this will be a topic for further analysis during the next releases, since we will be focusing more on data. Is also how we'll protect and guarantee that the data remains private and it's not corrupted. So that will be something that you'll be hearing more details in the next releases of DCSA.
Thank you very much.
Thank you.
Thank you. Bye-bye.